The next way that we can describe a graph is by its symmetry. So there's different types of symmetry, but we're going to look at graphical symmetry, which means we're going to look at two types of symmetry. Even, which is the y-axis symmetry, and odd, which is an origin symmetry. Now, I agree there's other types of symmetry. There's other types of graphical symmetry, but we're going to look at just these two types. So if it's not one of these two, then we're going to say it has neither. Not that it doesn't have any type, it's just neither of these two. Okay, so even, odd, or neither is going to be our options. Okay, so when we look at these, we can look at a graph and determine if it has symmetry. We can look at an ordered pair, and we can look at an equation. Okay, so when we look at the graph, we want to know if it's even, it's going to reflect over the y-axis. If it's odd, it's going to reflect over the origin. If I think about what does that do for the signs? Well, the signs, if I reflect over the y-axis, that means I would leave the y value the same, but the x value changes from positive to negative, or, negative to positive. The numbers stay the same. It's the signs that will change of the x values only. If it has odd symmetry, when I reflect over that origin, it's actually going to make the x and the y change signs. So if they were positive, they become negative. If they were negative, they become positive. Okay. So let's look at what that looks like, and then we'll talk about the equation. So if I look at this first example, and some people are just, it's easier for them to be able to visualize it reflecting, but I'll show you with the points too, so that you can verify that it's really happening. Okay, so if I look at this first graph, I notice that it is reflecting over this y-axis. If I can't tell that, then I would look at the point. So let's look at our point. We've got a point, let's say here at 2, we'll just rough estimate 2.5. It's not exactly, but it's okay. All right, so then I also find the point negative 2.5 on there. So I notice that the y values stayed the same and the x values changed signs. That indeed proves that it has even symmetry. All right, let's look at the next one. This one you might be able to see that it does reflect over the origin. If you can't see that, then again, we can pick a point. So let's say we have 3.25. So I can find the point -3, -25 on there. And what that means is that the x and the y have now changed signs. So 3 became -3, 25 became -25. So since the x and the y change sign, that would prove that it has odd symmetry. Okay, when I look at the next one, I notice that this looks symmetric, but it's not symmetric across the y or across this origin here. Another way to see that is that if I pick this point here, it does not reflect over here or it does not reflect down here. So this would be neither. So while I will agree that this graph, the shape of a W is symmetric, it's just not this graphical symmetry that we're talking about, right? So these points, all we want to do is imagine they were on a graph, and we want to translate them if it was even and if it was odd. Oh, I forgot another line there, I'm sorry. So if it was even, the new point, remember even means I'm going to change the sign of the x, so it'd be -3.7. If it was odd, then I would change the sign of the x and the y. So looking at that next one, again, if we wanted to have an even function, then we would change just the signs of our x value. So that's going to now be 2.5. If we wanted to if we wanted to find an odd symmetry, we would change the sign of the x and the sign of the y. Okay. It was the same thing that we were doing when we were checking our graphs earlier, but this is just, let's say we didn't even have a graph and they just asked me to find a point that could be even or could be odd, something like that. All right. Now, the last thing that we could find our symmetry from is an equation. Now, it's a little bit kind of tricky, but after we do one, it'll probably make a little bit more sense. So what I want to do, if one thing that I notice in both the even and the odd is that the sign of the x's change no matter what. The question is, does the y stay the same or does the y change? So that's what we want to do when we look at an equation. So what we're actually going to do, we're going to change the x to negative, and then we're going to look to see if we get the same or if we get something opposite. What we're looking at is the pattern of the signs. Okay, so what that looks like. Let's look at our first one here. I'm going to plug in a negative number. So if I plug in a negative, it doesn't matter what number I plug in. Okay, so if I plug in a negative and I square it, I get back a positive number. A positive 2 times a positive 2 gives me a positive in the end. Okay, let's look at the next one. I'm going to take this negative whatever number times a negative 7. Two negatives will, again, make a positive. And then there's nothing to plug in here, so that one's just going to carry down and I get positive. So let's look and see what was the original pattern. Well, the original pattern, the first thing was a positive, the second thing was a negative, and the the last thing was a positive. So now what I'm going to do is I'm going to look at the two patterns together and ask myself, are they exactly the same? Positive to positive, yes. Positive to negative, no. Positive to positive, yes. So they're either all the same or they're all opposites. If not, like in this case, we would say it is neither. Okay. Let's try it again. Make sure we understood what was happening. So I'm going to start off and I'm going to plug in a negative. So I'm going to have negative 3, number cubed, plus 4 times a negative number. Okay, so let's talk this through. If I take a negative number and I cube it, a negative number cubed is going to come back negative. Doesn't matter what number. And then I take a negative and I multiply by this negative, I end up with a positive. All right, so now we have a positive 4 getting multiplied by a negative, I end up with a negative. So my pattern is positive, negative. So I need to see if that pattern is the same or opposite of the original. So let's go back. Originally we had a negative and a positive. So let's look. Positive to negative, that changed. Negative, positive, that changed. So they both changed. So this is actually going to say that it has odd symmetry because they both changed signs. Okay. Let's look at this very last one. Almost done here. I'm going to plug in a negative and see what happens. A negative to the 4th power. So negative times negative times negative times negative, it becomes positive. So I take this positive 5 and multiply it by a positive number, I get something positive. So let's look at the next one. I've got a negative and I square it. A negative squared becomes positive. Negative times positive gives me negative. So my pattern is positive, negative. Let's see what we had originally. So originally we had a positive and originally we had a negative. So now I look, these plus plus, that's the same. Minus minus, that's the same. So this is going to have even symmetry because they both stayed exactly the same. So they either all change and it's odd, they all stay the same, it's even, or there's some weird combination and so we say it's neither.